4.4 Graphs of secant and cosecant functions. So we are done graphing until the very end, but we barely talk about graphing again in chapter 8. It is such a really small part of chapter 8. So basically we can say for now, we are done with graphing for a very long time. So if this was not the chapter for you, that's totally okay. You're not going to understand everything 100% of the time. All you need to know is, do you generally get it? Do you, if you took this to another class, could you start to refine your skills? Most of us can. But just know, you're not going to understand 100% of what you learn. A lot of things are going to take more and more practice. I do believe chapter 4 is one of them, especially 4.3, 4.4. It's going to take a lot more practice than the rest of the chapters, just because it's pretty tough graphing. And if you get it right off the bat, awesome. I'm really proud of you. If you don't get it and have to work hard, guess what? I'm still proud of you because you're working. All you have to do is just try, and you can graph this. It's obtainable. Remember, you have to graph it by hand. I need to see your work. You can use your calculator for checking, but I need to see your work. I need to see those steps, okay? Alright. Secant and cosecant functions. So secant function, we know what that looks like. It's secant x. Your domain is x such that x cannot be 2n plus 1 over pi times pi over 2. And our range is negative infinity, negative 1, union 1 to infinity. Meaning, do you notice here how it's never ever going to hit negative 1 or 1? It doesn't. Ever. So the graph is discontinuous at values of x in the form of x equals 2n plus 1 pi over 2, and has vertical asymptotes at these values. There are no x-intercepts. This is a big one. Secant and cosecant functions do not have x-intercepts. Its period is 2 pi. It has no amp, and it's symmetric to the y-axis. So whatever positive x you have, you also have negative x, because it's y-axis symmetry. So if you have negative 2, you also have positive 2. If you have positive 5, you also have negative 5 for your x's. Cosecant. So this is what it would look like. The graph is discontinuous at values of the form of x equals 2 pi, and has vertical asymptotes at these values. No x-intercepts, its period is 2 pi, it doesn't have amplitude, and it's symmetric with the origin. So if you have 1, 1, you also have negative 1, negative 1. If you have 2, negative 2, you would have negative 2, 2. Alright, if you were using your calculator, but you can't. You can use it to check, but you can't use it, remember, to actually give us the answer. So if you wanted to use your calculator, remember, it doesn't have these buttons, so you'd have to use 1 over sine or 1 over cosine, just like we did with tangent functions and cotangent functions. But what you would need to do is also put the original function in there. So if you had a cosecant 1/2 x, that's the same thing. So if you wanted to use your calculator, it would be 1 over sine 1/2 x. So for your y1, you would have sine 1/2 x, and your y2, you would have 1 over sine 1/2 x. So that's how you would graph your secant and cosecant functions. But how do we graph it by hand? So sketching graphs of cosecant and secant functions. Graph the corresponding reciprocal function as a guide using a dashed curve. So the first thing we're going to do is graph the reciprocal using dotted or dashed lines. So if you want to graph cosecant, you need to use sine as a guide. If you want to graph secant, you need to use cosine as a guide. You sketch the vertical asymptotes. They will have equations in the form x equals k, where k is an x-intercept of the graph of the guide function. Sketch the graph of the desired function by drawing a typical U-shaped branches between the adjacent asymptotes. The branches will be above the graph of the guide function values are positive, and below the graph of the guide function values when the guide is negative. Alright, example 1. Y equals 2 secant 1/2 x. So let's follow our steps. Our first step is to graph the reciprocal. So the function is secant. Therefore, we're going to use something else. We're going to use the reciprocal version. So literally, we're just going to replace secant for cosine. So we're going to use y equals cosine 2 cosine 1/2 x. So we literally just replace the function value. We're going to use it as a guide. So let's graph cosine. So we're going to graph our cosine function. So to graph our cosine function, we need the period. And the period is, that's our formula for it. So let's go ahead and graph our period. We have 0 is less than or equal to 1/2 x. That's less than or equal to 2 pi. So we have 0 is less than or equal to x. That's less than or equal to 4 pi. So that means our period is 0 to 4 pi. So now we have our period. We're going to do our intervals. So we're just graphing the cosine function like normal, like as if we were graphing every other cosine function. Basically, we're pretending this isn't there, and we're just graphing cosine. But don't forget, it is there. So let's do our intervals. We have 0 to 4 pi. So halfway between 0 and 4 is 2. Halfway between 0 and 2 is 1. So we have 1, 2, 3 pi. From there, we use our chart. Alright, so we're going to plug in each of our x's into y equals 2 cosine 1/2 x. So when x is 0, y is 2. When x is pi, y is 0. When x is 2 pi, y is negative 2. When x is 3 pi, it's 0. And when x is 4 pi, it's positive 2. Alright, so our first step was to get all the information about the reciprocal function, which in this case is cosine. So we did that. We found everything we need to graph our cosine function. Our second step are asymptotes. Alright, our asymptotes, they occur when x is 0. So asymptotes occur at x values that equal to 0. So the two x values that equal to 0 are pi and 3 pi. So our asymptotes are x equal pi and x equals 3 pi. Now, why is that the case? Because remember, x-intercepts, there are none. There are no x-intercepts for these two functions. No x-intercepts. What that tells me, since there's no x-intercepts, what that tells me is y cannot be 0. Because that's what no x-intercepts means. So that means whenever y is 0, that's our vertical asymptote. So if we have asymptotes at pi and 3 pi, we also know we have asymptotes at x equals negative 3 pi and x equals negative pi. We know this because of the symmetry. They're y-axis symmetrical. That's why we can say, well, if we have asymptotes at positive, we also have asymptotes at negative and vice versa. Our third step is to sketch the graph of y equals 2 secant 1/2 x by drawing U-shaped branches approaching the asymptotes. So meaning, let's put all the stuff we have now, and then I'll talk about how we actually find the secant graph. So remember, 1 through 2, those steps, that's finding the cosine graph, so we're going to be using dotted lines for that. Alright, so our asymptotes, we have 3 pi pi and negative 3 pi pi, and then our intervals are 0 to 4 pi. So in our graph, we have 0 to 4 pi. So that's 1 pi, 2 pi, 3 pi, 4 pi. On the other side, we have the same thing. We have negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. Alright, let's plot our asymptotes. So we have asymptotes at pi and 3 pi, and then the negatives of those. So we have pi, three pi, and then we have negative pi, and then negative 3 pi. Alright, so remember, we're gonna graph our cosine function like as is. Don't worry about the asymptotes, just graph it as is. So as is, using dotted lines, we have 0, 2. I'll do it in bright pink. 0, 2. Then we have pi 0. Then we have 2 pi negative 2. Then we have 3 pi 0, and then 4 pi 2. Now the other side, it's the same exact thing. We just follow along with the pattern. So you see how we're going to connect this with dotted lines. So it's going to go back down. So we'll have negative pi 0. Then we'll have negative 2 pi negative 2. Then we'll have negative 3 pi 0. And then negative 4 pi 2. So we just follow it along just like normal cosine function. So that's our guideline. Remember, guidelines are always dotted lines. So we have our guidelines and we have our asymptotes. So now we're going to create branches out of these points. So out of these points, we're going to create our branches using asymptotes. Okay, so in between, in the middle, see in the middle how we have these two asymptotes and we have this point? So it follows the asymptotes. And the same thing for opposite, for the bottom ones. So in between guidelines, in between asymptotes, they're parabolas. If it's on the upper half, they go up. If it's on the lower half, they go down. I'm talking about the halves of the coordinate plane. Now the other points that we have on opposite sides of the middle parts are these two points right here that are with asymptotes. So what we do is we branch it off coming from there. So since they're on the top part, it's going to be a happy face. Now we have no asymptote right here. We have no asymptote, so we're not allowed to do that. We have no asymptote. Same thing on the left side or the right side. Since there's no asymptote here, we are only allowed to do this. So if it's on the upper half, it's a smiley face. If it's on the lower half, it's a frowny face. So graphing secant and cosecant, it's the same situation. You're just going to graph the functions, the reciprocal functions of them. Let's try that again for example 2. Alright, example 2. So we have y equals 3/2 cosecant x minus pi over 2. So our first step is actually to use the original function of that. What we're going to do is we're going to use y equals 3 over 2 sine x minus pi over 2. So everything stays the same, you just change the cosecant to the reciprocal, and we're going to use that as the guide. So what we're going to do is just graph our sine function. So to graph our sine function, we're going to find the period first. So the period of a sine function, since there's multiple stuff going on to the x, it's going to be 0 is less than or equal to x minus pi over 2. That's less than or equal to 2 pi. So we're going to add pi over 2 to both sides. We have pi over 2 is less than or equal to x, and that's less than or equal to 5 pi over 2. Now we do our intervals. So our intervals are pi over 2 to 5 pi over 2. Now halfway between that, we get 3 pi over 2. Our first quarter point is pi, and our last quarter point is 2 pi. Alright, so we have all of our intervals. Now we can go ahead and find our y values attached to that. So we're going to plug each x value into 3/2 sine x minus pi over 2. When we plug in pi over 2, we get 0. When we plug in pi, we get 3 over 2, which is just 1.5. You can just use 1.5. It's easier to graph decimals. When we do 3 pi over 2, we get 0. When we plug in 2, we get negative 1.5. And when we plug in 5 pi over 2, we get 0. So what we can do differently now is we can actually graph this and then go back and use asymptotes. So let's go ahead and change it up a little bit. It just depends on how you like to view things. So let's graph our first step, our guide. So using our guide, we have our x values, our intervals. We have 0, we have pi over 2, we have pi, we have 3 pi over 2, we have 2 pi, and then we have 5 pi over 2. And then on the opposite side, we have the same exact thing except negatives. Alright, so our guideline in pink, our sine function, we have 0 pi over 2. We have pi 1.5. We have 3 pi over 2, 0. Then we have 2 pi, negative 1.5. Then we have 5 pi over 2, 0. And on the opposite side, we just keep following the pattern. So we would have 0, negative 1/2. Negative pi over 2, 0, negative pi 1/2, negative 3 pi over 2, 0, negative 2 pi, negative 1/2, and negative pi over 2, 0. And since it's a guideline, we always use dotted or dashed lines to connect them. Alright, so that's our sine function. Now we can use that to find our cosecant function. But before we do that, we need to find our asymptotes. So our second step is to find asymptotes. Remember, asymptotes are when y is 0. So y is 0 is here, here, and here. We have 3 asymptotes. So we have x equals pi over 2. We have x equals 3 pi over 2, and we have x equals 5 pi over 2. That means by default, we also have negative pi over 2, negative 3 pi over 2, and negative 5 pi over 2, because it's y-axis symmetry. So whatever x you have the opposite version of that. So let's sketch our asymptotes. We have pi over 2. We have 3 pi over 2. And then we have 5 pi over 2. And on the opposite side, we have the same exact things, just the negative versions of that. So we have negative pi over 2. We have negative 3 pi over 2. And we have negative 5 pi over 2. Alright, so we have all of our asymptotes. Now what we're going to do is use the points we have and create branches. So if the point's on the top, it's going to be a happy face. If the point's on the bottom, it's going to be a sad face. So our first point in between the guidelines. So our first point in between the guidelines, right here, I'm talking about that point right there. You see how it's on the lower half? So it's going to be a sad face using our guidelines. The third step is to sketch the graph using U-shaped branches. That's what we're doing. Alright, next, you see that dot in between the guidelines? Since it's up on the upper half, it's going to be a happy face. Our next dot right here, in between guidelines, so we're talking about in between guidelines. Only when you're in between guidelines is it a happy face or a sad face. So since it's on the lower half, it's going to be a sad face in between the guidelines. Our next point right here, since it's on the upper half in between guidelines, it's going to be a happy face. Next point in between guidelines, it's on the lower half, so it's going to be a sad face. And we have no more room, we have no more guidelines. That's it.